Hello everyone. I hope everything's working and you can see and hear me. Oops. Yep. Today we are talking about GPG and asymmetric encryption and related topics. And plan for today, we will make a brief introduction to all those topics. We will practice managing keys with GPG CLI, and we will try to use GPG key instead of SSH key, and also GPG-agent instead of SSH-agent. And also we will talk a little about hardware tokens for storing those keys. Let me check that stream works. Yep, it seems working. Good. And a little disclaimer, I am not a security expert. I will try to be careful as possible, but check my words twice before trusting them. And we won't learn how to use different tools like pass, git, and other things that uses GPG. We will only use JIT to explain how SSH works, to see if it works. And a little about asymmetric cryptography, also known as public key cryptography. It's basically a tool which allows you using two keys to do many practical stuff. For example, if you have some work and you want to make people trust this work, and you share that work on the internet, for example, your GitHub repository, or Git repository, or some binaries that you released, or something else, and you can attach a sign to this object, and people who have your public key can check if the signature is valid, and a valid signature can be made only with private key. Additionally, if you want to send some encrypted message or file to someone else, and you have his public key, we will find out later how you can obtain this public key. You can use this public key to encrypt this message, and only person who owns a private key can be able to decrypt it. Additionally, you can use this type of cryptography to authenticate in different services. Basically, someone who wants to allow you to be able to authenticate in service stores your public key somewhere. For example, for SSH, it will be known authorized keys file, and if your key presented in this file, you will be able to log in to this server. And also with your GPG key, you can create other keys and sign them. And also you can participate in the Web of Trust, but it's a big topic that we won't cover today. There's some confusion about names, and I will try to explain the difference between all those things. First of all, PGP, it appeared probably 30 years ago, and it was a proprietary software for encryption, and actually it was probably good, but it was proprietary and not usable because of that. Not very useful for some use cases, I mean. And the author of PGP created OpenPGP standard and described it in RFC, and you can find it in the internet. And GNU project later implemented this standard and called the implementation GnuPG or GNU Privacy Guard, which is basically implementation of OpenPGP plus some extensions. And there is obvious question, is PGP a good choice or not? Actually, it's not ideal. It's not ideal at all. There is some critique about this tool, and you can find links at the end of this file. I will share it later. Somewhere in the description I will put a link to it. But you can find this link right here, and it explains a lot of downsides of GPG and PGP. But it's a good tool, and it do a job. And we will try to understand how to use it. But first of all, before trying to use it, we need to get some background knowledge about GPG key structure. And despite the name of GPG key, it's not a key. It's actually a little more than just a key. It's a structure that contains primary key, primary identity, and some extra identities and subkeys. Subkeys can do everything that primary key can, except one thing. And a little later we will understand what's the difference. And identity used to understand to make a connection between a key and some person, because using only digits and some letters, it's very hard to remember which key belongs to each person. Yep, and let's go back to our document, and let's start from a very simple at first thing, but it's actually not so simple, because depending on your security requirements, it should be done in different environments. Creating key actually requires a lot of entropy, and also to be sure that your key not compromised, it should be done in some isolated environment. Probably it should be some machine without network access, and also booted from trusted live CD, which doesn't have a lot of things in it, to be sure that nothing spies on you and nothing compromises your key. That is why it's better to do the following operations in pretty safe environment. But for now, for example, I will be doing it on my laptop, but later I will delete those keys and won't use them. And first of all, we will be generating our GPG key, and we will be doing it in expert mode to be able to set capabilities of the keys. And there are 4 capabilities for each key, and each key can have 4 of them. I mean 3 of them, and primary key can have 4 of them. But it's a good practice to set one capability per key or per subkey, and I will explain a little later why. Let's start from generating our key, and we will pick RSA number 8, and in the brackets or parentheses you can see that it says set your own capabilities. It's necessary to it's necessary because by default this tool generate your primary key with 3 capabilities: sign, certify, and encrypt. But we won't use all of them. Hello, Sartor. You can try to use GPG2. Probably GPG can be a link to a different utility which doesn't work. And also you can try without full, maybe it also works. Yep, GPG2 works. Good. Okay, and as you can see, there are 3 capabilities here: sign, certify, and encrypt. And for primary key, we will be needed only to have certify capability for creating subkeys. And we don't need encrypt and sign, because we won't be using our primary key for signing or encrypting or authentication or something else. That is why I will toggle sign capability and also toggle encrypt capability, and I can toggle certify capability because primary key always has such capability, and all subkeys doesn't have certify capabilities. For the key size, we will pick 4096 bits long. You have to be careful with it because, for example, some hardware tokens doesn't support such long keys, but in most cases 4000 is okay. And actually we don't need to our primary key to expire, because we won't be using it anywhere except generating other subkeys. That is why we won't be revoking it, because it will be stored only on encrypted flash drive somewhere outside of reach of anyone. And it's correct. Good. Now we need to provide our real name. I will say Tropin, and email address tropin@example.org, and test key as a comment. Looks good to me. I will say OK, and it will ask for a password to protect my GPG key. I will use very strong password that probably no one will break, and it's generated a new key. And now I actually can list all the keys, and as you can see right now it shows pub, which means public, and ID of the key, and also user ID or user identity, which is primary identity for this key. But this key can't do anything now, because it can only create subkeys. It can't encrypt, sign, or authenticate. Okay, and let's check our secret keys. And we have one secret key. You can see here, sec means secret. And it has the same key ID. Let's edit our key. Edit key. Boom. And now you see the prompt for GPG. And I can type help to see all the commands available for me right now. And we will create few subkeys. And each subkey will have only one capability, and we will be using it for only one purpose. For now, I will create RSA key links expires 1 year, for example, and is correct. Really create. Good. And now I need to retype my password for my primary key, and it generated another key, and you can see usage S, which means sign. And now I need to actually I want something like okay, it's fine. Let's find another command that's allows us to edit keys. Set pref notation. Okay, additionally, later, if I want to change expire date, I can select key. As we can see now, the asterisk near the key, and type expire command. And this command can be used to update expire date for subkey. And now you can see that it expires one more year later than it was. Sartor says, I had some interesting output, not enough random bytes available. Please do some other work to give us a chance to collect more entropy. As I already said, it's necessary to have a lot of entropy to make generation of the key secure. You can run generation of the key and watch some videos in the browser to click somewhere, move your mouse, and so on. Or you can use some hardware token to generate entropy, or some special tools for it. But the easiest way probably just to run this command one more time and to do some actions. Good. Now I need to generate one more key for authentication. Add key, encrypt only, sign only. Actually, it's not what I want. Okay, I know what the problem is. Probably I need to select expert. Oh, I also didn't save my changes. That is why here you can see only one key. Let's generate one more key for sign. And now you can see that it has more options because I typed expert parameter to GPG. And let's generate RSAs at your own capabilities. And as you can see, by default it's sign and encrypt, but I need only one subkey for one capability, and the subkey will be for sign. Q for finished. Hop, expire 1 year, correct, really create super strong password, and it generated because I already have a lot of entropy. Now we can see two keys, and I can say save my changes. And now when I edit key one more time, you can see that this key presented here. And let's create key for authentication. And we won't be creating a key for encryption because it will be the same as the previous. We toggle sign and encrypt capability, but enable authenticate capability and finish. Size 1 year, correct, really create super strong password, and we generated two subkeys, and those subkeys will be used to perform all our operations. And our original key will be used only for creating and updating expiration date or revoking our subkeys. And it's a good practice to backup your keys somewhere and use only subkeys, and until you until those subkeys not expired, you don't need your primary key, or not compromised. You don't need your primary key, and it can be stored offline somewhere in the safe place. Okay, let's try to backup them. here I wrote a simple example how to backup them, but probably don't need to backup them in your home folder. You have to mount a USB storage or some other storage. You have to create an encrypted partition, mount this encrypted partition, and make your backup to this encrypted partition. And you can do two backups. First one for your whole key, which includes your primary key and all subkeys, and another backup for your subkeys only. We will need it to make our primary key not available in our key chain, because we don't need after we finished with generating subkeys. Okay, let's backup all that stuff. It will ask 2 times for our very secure password. And here in GPG backup, you will see 2 files, which is your secret keys. And now I can delete secret keys for Tropin example.org, and it will ask me if I'm sure that I want to delete them. I will say yes. This is a secret key. Yes. One more time and one more time. A lot of questions to remove your secret key. And also I want to delete a public keys in my as you can see, if I ask for secret keys, it doesn't have any keys right now. And if I ask for public keys, it will say that there are 3 keys here. And probably you already understood what this notation means. It's a public key, it's subkeys, it's user identity. And also to list keys, you can add with kgrip parameter, which will show ID that can be used in some other tools, or you can use key format probably. Okay, let's find it's in manual. I want a different format for showing my keys. ID format. Okay, list keys ID format long. Now you can see that each subkey will be presented with additional information about it that can be used in your configuration file of JIT tool or somewhere else. For example, for initializing your password store in pass utility. Okay, we backed up our key. We also deleted our private keys, and let's delete our public keys. You can specify here key ID, or for example, we can delete subkey probably by using sorry. Yes, and GPG actually you can use any of those identifiers, and it will delete the whole key, which contains your primary key and all subkeys. Okay, and now we can import back our backed up keys with following commands. but we will import only subkeys. We need to type our very strong password, and as you can see, now we have the same notation, or -k means the same as list secret keys, kid format long. It looks very the same with few exceptions. It doesn't have ultimate here, and it has a sharp at the end of sec. And if we consult the manual, GPG, which means a sharp after the initial text sec or SSB means that the secret key or subkey is currently not usable. And here in our example, it is because we imported only secret keys, and our primary key is not imported, and that means that if we run expert edit key command and we'll try to add key, it will say that we can't add key. And if we will try to change expiration time for our primary key, it will fail with error about no secret key. That means after you finished all your work with creating subkeys and backed everything up, you can import only subkeys, and you will be sure that if your machine will be compromised, you won't lose the access to primary key, and you will be able to revoke all your keys using this primary key, because you can run another machine, take your backup, and create revoke certification and revoke your keys. It's pretty good idea. And another good idea, not to store your keys and subkeys on your machine, but store them in a special hardware token. And those hardware tokens can store keys, but they can't get access to those keys. That means if you imported your keys to the token, nobody, even you, even with password and your primary key, won't be able to get those primary keys from this token. It's probably most secure way to store your secret keys right now, but hardware tokens a little expensive, and it requires a little bit more setup. For our example, we won't be using token for today, but I recommend you to check some available options and to prefer hardware tokens for storing your keys. Okay, we backed up our keys, and also we can publish our keys for other people to use. For example, if someone wants to send us some encrypted file or encrypted email, he needs to obtain our public key first, and we can share it with email or IRC or some instant messenger. We can share it on our website, and also we can share it with key server. There are a few key servers, and we can access them with GPG utility, and we can use send keys option, which doing the same as export option, but sends our public export options exports our public keys. But sends them to key server, and also we can specify which key server to use using key server option. I can't find. I found this option. Just specify key server option and name. and it will look something like send keys. Let's start with key server. For example, Ubuntu key server ubuntu.com send keys and Tropin example.org. I won't be running this command because I don't want to share this test key for someone to be confused. I will be able later to use the same GPG utility to make some search on this key server like that. I have my old GPG key available on key server ubuntu.com, and I'm able to search for this key using my email, or I can use my key ID, or probably I also can use my real name to search a key like that. Yep, and it founds. And if I try to find test person, too many requests. Oh, too many keys exist for test person. Actually, many people created test keys with test person, and it found a lot of options, but not existing test person will say that there is no keys available on this key server. And there are a few more options that you can use. It's up to you which one you prefer. Web email is most basic, but requires your involvement in the process, and key server allows to any person to obtain your public key and use it. Okay, let's make some example usage of GPG keys, and we will be using our GPG key for authenticating and cloning our Git repository from GitHub. I prefer to use GPG keys instead of SSH key because it's easier to maintain only one key for all the tasks, for signing commits, for signing tags, for encrypting my passwords, and for authenticating on remote servers, and use only one agent. I use gpg-agent for both SSH and other stuff, and it's a little easier than everything in one place, but it's absolutely okay to use both gpg-agent and ssh-agent. Okay, let's try to use our key with authenticate capabilities with key group. I already configured my GPG agent to act like an SSH agent, but I placed links to the instructions how to set up SSH your GPG agent to emulate SSH agent. Okay, you can see my config. I use enable SSH support in it, and I use pretty big cache time to enter my password only once a year. But probably if you use hardware token, you don't need time to leave option. You will be unlocking your hardware token with hardware token mechanism, not with GPG, and GPG won't be caching your keys. Everything will be done on hardware token. Good. Our GPG agent already works as ssh-agent, and the only thing that I need to do, I need to check if my key presented, but it's not, and to add my key to list of keys, I need edit file called GnuPG ssh control, and here I add a key that should be used, and now ssh add -l shows a public key that I can use as SSH key. And here I will open my GitHub, settings, SSH, and new SSH key, and we'll paste it here, gpg key. And I need to type my GitHub password. Now you can see there are two keys, one of them GPG and one of them SSH that I previously used. And now I will try to clone a repository, or I can try to log into GitHub, and it will ask a passphrase for my SSH key. I will enter my super strong password, and it will say that I was successfully authenticated. And if I comment this key, now you can see there is no keys in ssh-agent, actually gpg-agent, which emulates ssh-agent, and ssh fails with permission denied. And now I returned this key back, and as you see, it's already cached in gpg-agent, and it doesn't ask for one more password, it just works. And now I will be able to clone, for example, my RDE repository, git clone. Yep, it works as expected. Now I have only two subkeys in my key chain for signing and authentication, but in reality I would like to have one more for encryption. And my primary key exists only in my backup, and even if I lose all those subkeys, for example, if my laptop or my desktop will be compromised, I won't be too sad, because I will be able to revoke them and to make people know that those keys are not longer mine or under my mind control. Okay, I think that it's pretty much it for today that I wanted to tell you about GPG. And if you have any questions, you can raise a hand and ask it. Additionally, I placed few links that I used for preparation of this talk. Actually, I used a little more than that, and I will place also this link here. It's a good reading, which explains not only UBK related configuration of GPG, but also a lot of details about generating keys, backing them up, and so on. all those topics applicable for GPG, not only for UBK, and some additional information about usage of hardware tokens. The same story for Arch Linux wiki. It has a lot of information, not only about hardware tokens, but about GPG, and more specialized blog, which has a very nice picture that I used to explain GPG key structure, and a blog about GPG PGP problems, which also says about GPG problems. It's a good article to read, but keep in mind that probably GPG is good enough software to use. Okay, thank you everyone for your attention. I hope you enjoyed the talk. See you later. Bye.